Okay, today we want to look at what's called determinants. This is another method that we utilize to solve systems of equations. Okay? And I think it's pretty easy, so it's pretty impressive. So hopefully you can follow along. The first thing is just how to solve a determinant. Okay? So I'm just going to use some numbers real fast. So let's say I have this matrix, 3, 1, 2, negative 1, and I want to find the determinant of that. Okay, so these vertical lines, similar to absolute value, that means you're to find the determinant of it. Okay? So, it's really simple. You start with the top left, and you do this diagonal. 3 times negative 1, minus, and then you do the other diagonal, 2 times 1. Okay? And that's something you guys frankly have to memorize. That's how you evaluate a 2 by 2 determinant. Start with the top left, this diagonal, minus this diagonal. Okay? That's it. So if you can evaluate that for me, please. What do we get? Negative 3 minus 2, which is negative 5. Okay? So more generally, if I start using A1, A2, B1, B2, we can develop the formula for this. So if I have a 2 by 2 determinant, where my coefficients here are A1, A2, B1, B2, what would be the applicable formula? A1 times B2 minus? A2 times B1. Okay. Now again, I don't expect that you have to memorize that as much as know how it works. This diagonal minus that diagonal. Okay. All right. So I need to know how to evaluate a determinant first before I can go about solving a system. Okay? So let's do a system here. Let's say I have A1x plus B1y equals K1. A2x plus B2y equals K2. All right? So this will be a 2 by 2 system of equations. And I'm using A1s and A1, A2, B1, B2, K1, K2. Those will all be replaced by numbers, right? Coefficients from the variables and numbers on the right-hand side. Okay, so here's what's brilliant about the determinant method is we can go right to our answer for this system. And what I want you guys to pay attention to, what's more important today, is the pattern. Okay, so watch how I develop the solution. This is the solution to this. X equals and Y equals. They're going to have a determinant in the top and a determinant in the bottom. That's the first thing, okay? So X equals, Y equals, there's going to be a determinant in the top and a determinant in the bottom. The bottom's the same. You take the coefficients from the x's and the y's and you just plop them there. So all you're going to have here is A1, A2, B1, B2. A1, A2, B1, B2. Now what I don't want you to memorize is this. What I want you to memorize is what's down there. Okay? So in the denominator, the determinant that's down there is the coefficients from the x and y's. Make sure it's in standard form first though. Okay? You have to put these in standard form first for this to work, right? Okay, now I'm about to do something. I don't want you guys to copy what I'm about to do. Just pay attention for a second. I'm just going to put A1, A2, B1, B2. Please do not copy this down. A1, A2, B1, B2. Okay? Does everybody see how I have A1, A2, B1, B2 everywhere? Mm-hmm. Now, here's how it works. What you're going to do, what I want you to actually write down, is think of the first column as the x column and the second column as the y column. Okay? Similarly over here, this is the x column and this is the y column. When you're actually solving it, what you need to do is replace whatever variable you're looking for, that column, with the k's. Okay? So here's what I want you to memorize. In this numerator here where I'm solving for x, I want to replace the x column. So instead of A1, A2, I'm going to put K1, K2. Okay? That's the formula. You're going to put the K's in the correct spots. Now in the y equals, instead of the y column, instead of B1, B2, you're going to put K1, K2. Okay? That's the formula. So go ahead and write that down. That's the formula. But I want you guys to see where it comes from. Okay? Let us do an example. Let's say our equation is x plus y equals 5 and x minus y equals 3. And I'm going to solve this system of equations using the determinants method. Okay? All right. So first of all, let's make sure we have the coefficients. If it's just x, what is the coefficient of just x? 1. So I have a 1x, a 1y, a 5, a 1x, a negative 1y, and a 3. What if there was no x here? What would the coefficient be? If there was no x there completely? 0. Right. Great. Okay. All right. Using this formula, we should be able to solve it. Okay? So my x, let's do the determinant of the bottom first. Since the y determinant and the x determinant both have the same bottom, I'm replacing just the coefficients of x and y in the bottom. Okay, so what is going to go there? 1, 1, 1, negative 1. Does everybody see that? So it's the numbers from the left, the coefficients from the left are going to go in the determinants in the bottom. Okay?
Does it say x plus 1y and x minus 1y, or is that a...
1x minus 1y equals 3. So originally it was just minus y, but I put minus 1 there because that's the coefficient. Okay? Okay, guys, go ahead and evaluate that bottom determinant for me. Should only take a second, right? Diagonal minus diagonal. Okay, we need to know what that is. Everybody know what we're doing? 1 times negative 1 is negative 1. Minus 1 times 1 is 1. What is negative 1 minus 1? Negative 2. Great. So this bottom here is just negative 2. Okay, great. So we know the denominator is negative 2. And now I just have to evaluate the numerator. Okay, so let's make sure we get this right. In this one, I'm going to replace the x column, which is the first column, with the k's, which is the numbers on the right side. So 5, 3, and then can somebody tell me what goes in the y spot?
1, negative 1.
1, negative 1. Great. All right. In the second one, I'm going to replace the y's with the 5, 3. And what's going to go in the first column? 1, 1. The x's. Okay? Got to memorize that. That's the pattern. Okay, I need you guys to evaluate those two determinants. It should only take 30 seconds, right? Diagonal minus diagonal. 5 times negative 1 is? Negative 5 minus 3 is?
Negative 8.
What is 8? Negative 8 divided by negative 2?
It's negative 4. Positive 4.
X is 4. It's done. Let's come over here. We have 1 times 3.
3.
Minus 5 times 1. 3 minus 5 is?
Negative 2.
Negative 2 divided by negative 2?
Is a positive 1.
Positive 1. Great. And just like that, we're done with this problem. So again, write your answer as a solution, as an ordered pair or an ordered triplet if we're doing 3 by 3s. So my answer is 4, 1. What if I look at this answer and I'm like, ooh, I'm not positive that's right. What do I do?
Plug it in.
Plug it in. Is 4 plus 1 equal to 5?
Yes.
Is 4 minus 1 equal to 3?
Yes.
We're right. Did we understand this problem? It's okay. We're going to do several more. Just memorize the pattern. Don't try to remember all of these A1, B1 stuff. Just memorize the pattern. All right, let's take a look at this one. X plus 2y equals 7. 10 equals 2x plus 2y. All right, before jumping into that problem, how is it trying to trick you already?
It's putting the
10 the other side.
Yep, it's putting it out of order. So job 1, put it in the correct order first. Put in any missing coefficients. Get it in standard form first. Once you've done that, I would like you to solve the denominator determinants, okay? So see if you can do those 3 things. While you're working on it, I will do it myself. Put it in correct order first. 1x plus 2y equals 7. 2x plus 2y equals 10.
Wouldn't it be negative? How is that possible? Oh wait, never mind. Never mind, you just rewrote it.
X equals determinants over determinants. Y equals determinants. Can somebody tell me what goes down here first?
1, 2, 2, 2.
1, 2, 2, 2. How do I know that? It's just the stuff on the left, right? Okay, solve that for me. Should only take a few minutes.
Sir,
Yes?
why don't you put the 1, 2, 2, 2 on the top? Why do you want to do the bottom?
Because we always do the bottom first.
Why do we always do the bottom?
Well, I mean, so you could do the top first if you want, but I think
Will it still work? Or I just want to understand how this works because I don't really get how this correlates with our section before 8.
okay, so I will show you in just a second. But right now, the coefficients of the x and y always goes on the bottom. And so I'm just getting that out of the way. Yeah.
We don't need to include the numbers that don't have any coefficients.
Well, that's going to happen in the numerator. That's why I'm holding off on that. Yeah. The denominator is easier. All right, did everybody get -2 for the bottom? Because you have 1 times 2 is 2, minus 2 times 2 is 4, so you have 2 minus 4. Right? Okay, hopefully that's the easier one. Right? Now I'm going to go back and I want to replace whatever column I'm doing. So if I'm doing x, I'm going to replace x with the numbers on the right. So 7, 10, 2, 2. And what goes over here? Replace y. 1, 2, 7, 10. Great. Memorize that pattern. Okay? And solve those. So notice, you replace the x column with the numbers on the right for this one. You replace the y column with the numbers on the right for that one. That's the pattern. Okay? Seven times 2 is 14. 14 minus 20 is? -6 divided by -2? Positive 3. We solved x. Now I need you to solve y. 1 times 10 is 10. 2 times 7 is 14. 10 minus 14? -4 divided by -2? Our solution is 3, 2. Plug it in and check. 3 plus 2 times 2. 3 plus 4 is 7. Yes. 6 plus 4 is 10. It checks. Okay? All right. Now you need to know how to do a 2 by 2 because the same method applies to a 3 by 3. All right? Which is what we've been doing the last couple sections. So yes. Now let's see how a 3 by 3 works. Okay. First I want to show you just how to evaluate a 3 by 3 determinant. All right, here we go. Let's say I have this determinant. 2, 3, 1, 1, 0, negative 1, negative 1, 2, 4. Okay, please write this in your notes. This is how you evaluate it. All right? The first thing that you're going to do is copy the first 2 columns again. So in your notes, copy down the first 2 columns again. Okay? Please stay with me because I don't want to lose you. Is everybody okay there? All I've done so far is I've copied down the first 2 columns again. Now, starting with the top left corner, we're going to form 3 diagonals. Okay? So starting here on the top left, there's 1 diagonal, 2, 0, 4. There's another diagonal, 1, 2, 1. And there's another diagonal, negative 1, 3, negative 1. Okay? There's only 3 possible. Now, in those 3 circles that I've made, your job is to multiply those numbers together in those circles and then add them. Okay? So here's how it looks. 2 times 0 times 4 is 0. 1 times 2 times 1. 2. So add that, 0 plus 2. Negative 1 times 3 times negative 1 is positive 3. So I'm adding 3. Okay? All right. Then, starting with the bottom left corner, you form the 3 other diagonals. So it looks like this. 1, 0, negative 1. Negative 1, 2, 2, and 4, 3, 1. Okay? And you're going to multiply those numbers together, but instead of adding those 3, and this is the thing, you subtract those 3. Okay? So it's plus, 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 minus, minus, minus. All right, 1 times 0 times negative 1. Well, anything times 0 is 0. So I'm going to put minus 0 there just because it's a reminder that we're subtracting. Negative 1 times 2 times 2, that's negative 4, right? Minus minus 4 is? Plus 4. Okay? So I'm subtracting negative 4. 4 times 3 times 1 is 12, positive 12, so I subtract 12. Plus, 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 minus, minus, minus. And that's it. Okay? Now I need you guys to add these 6 numbers and tell me what it comes out to. 0 plus 2 plus 3 is 5, plus 4 is 9, 9 minus 12, negative 3. That's it. A lot has happened, so please make sure you understand the pattern. First thing I did is I wrote down the first 2 columns again. Starting with the top left, I formed 3 diagonals. Within those diagonals, you multiply those numbers together, and then you add those 3 things.
So you multiply those rows and just get these numbers?
You multiply the diagonals.
Diagonals, yeah.
And you add them together.
Okay.
Then, one second. Then I do the bottom diagonals, left to right going upward, and I subtract these multiplications. Okay? Yes, sir?
So there's no x or y variable, there's just an answer?
I'm just showing you how to do the determinant.
Okay.
We're about to do an x, y, z variable. Yeah.
How is a negative 3?
You have 2 plus 3 is 5. 5 plus 4 is 9. 9 minus 12 is negative 3. Okay? You're just adding and subtracting.
Oh,
Okay. So, how in the world do I make use of this to solve a 3 by 3. Now, if you guys have worked on your homework, and I know some of you have, these are long problems. These 3 by 3s, if you do them algebraically, they take a long time. If you try to do matrices in row reduced form, they take a long time. With determinants, they still take a pretty long time, but I think a lot of students find this method easier. Okay? Here we go. A1x plus B1y plus C1z equals K1. A2x plus B2y plus C2z equals K2. A3x plus B3y plus C3z equals K3. If you have a 3 by 3, 3 sets of equations, 3 unknowns, and it's put completely, perfectly in standard form,
Yes.
you can give the answer to this using the determinant method. Okay? Here's what my answers look like. X equals some determinant divided by another determinant. Y equals some determinant divided by another determinant. And Z equals. All right? Now, I want you guys to tell me what goes where using exactly what we did in the 2 by 2. Let's start with the denominator. What numbers do you think go in the denominator on this? Using A's, B's, and C's, please.
A, B, and C's, yeah.
A1, A2, A3, B1, B2, B3, C1, C2, C3.
Exactly.
Yeah.
All the coefficients on the left go in the bottom, just like in the 2 by 2. Okay? So A1, A2, A3, B1, B2, B3, C1, C2, C3. So luckily, we only have to do this one time, and it's going to be the same denominator for all of them. So just the A's, then the B's, then the C's. Okay? All right, now here's what I'm about to do. I am going to copy the same thing in the top, except for the column that's going to be replaced. Okay? So for instance, in the X column, I'm not going to copy the X column. I'm going to leave that alone. But I am going to copy the other two. The Y column, I'm going to leave alone. And I'm going to copy the other two. And finally, the Z column, I'm going to leave alone. And I'll copy the X and Y column. Because I want you guys to see, again, the only thing that happens is I replace the K's in the missing column. Okay? So over here, it's the X column. You replace the X with the K's. K1, K2, K3. In this example, it's the Y, so I'm replacing the Y column with K1, K2, K3. And over here on the Z, I'm replacing the Z column. Here's what I don't want you guys to do. I don't want you to memorize all of this. Just memorize the pattern, okay? Trust me, you don't want to go home and try to memorize all of those different individual things, okay? Just memorize the pattern. The left coefficients go on the bottom, and then in the top, you only replace whatever variable you're looking at, X column, Y column, or Z column, with the numbers on the right. That's it. That's what you memorize. Okay. Let's do one, shall we? Here we go. I'm going to put it in order for you. 3x plus 2y plus 0z equals 12. 4x plus 0y plus 2z equals 16. 0x plus 4y plus 3z equals 24. Now, when you write that down, keep in mind, the book or homework problems or on a test, I'm never going to have 0z there. It's just going to be missing, right? But I expect you to put in 0z just so everything lines up when we go to the determinants. Okay?
Oh wait, so like some problems would have like 3x plus 2y plus 12, and then the bottom would have the 3.
Exactly, and they could be out of order. They could have the numbers over here and the x and y's over here. Your job is to put it in standard form first. Okay. They could throw all kinds of things at you over there. Put it in standard form, get it to look exactly like that first.
What's the other form other than standard form?
Well, non-standard form, so they could put it in any other form.
Yes, we do like
So just make sure you put it in x, y, z number. Okay. Okay. The first thing I want all of us to do is the determinant that gives us the denominator. Let's just do that first. Okay? So what determinant is that? 3, 4, 0, 2, 0, 4, 0, 2, 3. This is the determinant for all the denominators. See this.
Copy the
First two columns, copy them down. Okay? Now instead of drawing circles, I'm just going to do lines. All right? Starting in the top left, we got 3, 0, 3. Does everybody see that? Plus 2, 2, 0. Plus 0, 4, 4. Just trying to do a little faint line here so you can see that. All right, let's make sure we get this. 0 plus 0. Having zeros is so great in determinants. Okay? All right, then from left to right going up, 0, 0, 0, 4, 2, 3, 3, 4, 2. Everybody see that? So, minus 0. What is 4 times 2 times 3? Minus 24. What is 3 times 4 times 2? 24. So another minus 24. What do I get when I add 0, 0, 0, 0, negative 24, and negative 24?
Negative 48.
Great, negative 48. So does everybody see that the denominator determinant for all of these values, x, y, and z, is going to be negative 48? Okay? How many more determinants do I need to solve? 3. 1 for x, 1 for y, and 1 for z. All of the denominators are negative 48. Okay? Okay. Here's what I have so far. I'm halfway through my problem. I have all the bottoms, and I need a determinant for x, y, and z, just the numerator parts now. Okay? All right. Can somebody tell me, just by looking at this problem, what the x numerator determinant is going to look like? 12, 16, 24. I replace the x column with the numbers on the right, and then what comes next? 204, and then what? Does everybody see where this came from? We're trying to solve for x. You replace the x column with the numbers on the right. Okay.
And then 12, 2.
So I need you guys to solve this, evaluate it. Repeat the next two columns, and then do your diagonals. Okay? Solve this for me.
Now, you just find the terms of x. So if you're saying
Make sure you get the diagonals right. We have 12 times 0 times 3, which is 0. We have 2 times 2 times 24, right? So plus, what is 4 times 24? 96 plus 0 times 16 times 4 is another 0, right? So far with the 3 columns, diagonals going down, I have 0 plus 96 plus 0. So everybody have those 3 numbers. 12 times 0 times 3 is 0. 2 times 2 times 24, you guys told me is 96. And then 0 times 16 times 4 is 0. Okay. Now going upward, we're going to subtract. 24 times 0 times 0, so minus 0. 4 times 2 times 12. 96, okay, so minus 96. And then 3 times 16 times 2. 96. Is that 96? So minus 96. Okay. So I have 96, minus 96, minus 96.
Negative 96.
What is negative 96 divided by negative 48? Positive 2. And we are done with x, guys. X is 2. Is this difficult? No, not at all. You're just multiplying and adding, okay? The thing that's difficult is understanding the pattern. Make sure you get the pattern, and then it's really relatively easy. Okay, let's move to y. Okay, the x column is going to be 3, 4, 0. The z column is going to be 0, 2, 3, right? The only column that's going to change is the y column. And instead of 2, 0, 4, which is normally what I would put in the y column, I'm going to put 12, 16, 24. Okay? So that's the pattern. Memorize the pattern. Now, solve that determinant. Copy the first 2 columns one more time. Then start getting your diagonals figured out. Okay? And you can use a calculator. You know, some of these numbers are getting kind of large. That's totally fine. Use a calculator.
How did you get 0 in the middle?
Okay. First diagonal, 3 times 16 times 3 is 144.
Yeah.
Second diagonal, 12 times 2 times 0.
Okay.
0.
Sorry.
Next diagonal, 0, 4, 24, 0 again.
Yes.
Next diagonal, 0, 16, 0, 0. Next diagonal, 24, 2, 3 is 144, but I'm subtracting. And final one, 3, 4, 12 is another 144, and I'm subtracting again. If you add those numbers together, you get negative 144. And what is negative 144 divided by 48? Positive 3. We're so close to being done. Only one more determinant to do, and that's z. So you guys go ahead and do it. Replace the z column with the 12, 16, 24. This should be your determinant, right? I'm only replacing the z column with 12, 16, 24. All right, solve it for me, please. Did everybody get these 6 numbers? 0, 0, 192. 0, negative 192, and negative 192.
Yeah.
Great. What does that add up to? Negative 192. And what's 192 over 48? 4. What is my answer to this problem? 2, 3, 4. Ordered triplets. You have 3 methods for solving these 3x3 systems. The algebraic method, okay, or using matrices in row-reduced form, right, where you're trying to get the 1, 0, 0, 0, 1, 0, 0, 0, 1, or you have the determinant method. Okay? On the test, when we have our test, I won't tell you which one to use. You utilize whatever one works best for you, okay, and just show the work for each step.